Welcome to this expert-level training module on Microsoft Foundry. Today, we will master the critical concepts of AI model components by identifying appropriate model deployment options and configuration parameters. Welcome to our advanced training on artificial intelligence architectures. Today, we are taking a comprehensive deep dive into a critical phase of the machine learning lifecycle, identifying appropriate model deployment options and configuration parameters within Microsoft Foundry. Once you have successfully explored the Foundry model catalog, analyzed the various model cards, and selected the perfect foundation model for your enterprise workload, you must understand that the model is still just raw computational intelligence resting in a repository. To actually utilize it within a custom client application or an autonomous agent, you must formally deploy it. According to the official Microsoft training documentation, deploying a model takes an AI model and makes it actively available for use in production through a stable, scalable, and highly secure API endpoint. This deployment process essentially transforms a static algorithmic model into a living, breathing web service that your applications can call continuously via standard network protocols. Why is this architectural step absolutely necessary? Deploying a configured model helps ensure consistent, predictable performance and unshakable reliability under heavy user demand. It allocates the exact hardware required to run complex neural networks efficiently. Furthermore, establishing this formal deployment boundary allows developers and system administrators to actively prevent unauthorized or unsafe use by routing all inbound inference requests through authenticated security layers and rigorous content filters. Throughout this intensive module, we will thoroughly explore the specific deployment parameters you can customize in Foundry, such as selecting deployment types and enforcing rate limits. We will break down exactly what happens under the hood when a deployment is triggered in the cloud. We will also dive into the critical runtime configuration parameters like temperature settings and system instructions that dictate exactly how the model behaves when responding to user prompts. By mastering these deployment options and configuration parameters, you ensure your enterprise AI applications are not only highly intelligent, but also cost-effective, perfectly governed, and ready for massive production scale. While model deployment can be achieved via the Microsoft Foundry portal user interface, enterprise developers frequently automate this process using infrastructure as code. When configuring a new model deployment in Microsoft Foundry, the very first critical parameter you must define is the deployment type. The deployment type is an architectural setting that fundamentally determines exactly where and how inference is processed within the Azure cloud infrastructure. According to the documentation, deployment types are directly tied to your application's specific throughput and data processing requirements. Foundry provides highly flexible deployment mechanisms that let you explicitly tailor performance, cost, and governance to match your exact enterprise needs. The primary deployment types available include standard, global batch, and regional provision throughput. A standard deployment type is typically used for traditional, synchronous, real-time workloads, where a client application requires an immediate response, such as a live customer service chatbot or an interactive coding assistant. However, if your application processes massive amounts of data, asynchronously like summarizing thousands of daily call center transcripts overnight, the global batch deployment type is significantly more cost-effective, routing the workload to available global compute resources, where immediate latency is not a strict requirement. Finally, for mission-critical enterprise applications that demand absolute guarantee of performance, with zero risk of noisy neighbor degradation, architects select regional provision throughput. This premium deployment type guarantees a dedicated amount of processing power exclusively for your application within a specific geographic region. Choosing the correct deployment type is a mandatory configuration step that requires deep collaboration between AI engineers and business stakeholders to perfectly balance the desired user experience against strict infrastructural budgets and latency requirements. Making the right choice here guarantees your AI service operates seamlessly. In code-driven infrastructure deployments, the deployment type is explicitly declared as a string parameter within the JSON or bicep template. Defining a standard SKU versus a provision SKU directly dictates the underlying compute cluster allocated by Azure, instructing the platform on how to handle the scaling and routing of your incoming HTTP requests. This diagram breaks down the decision tree for selecting a deployment type. After establishing the overarching deployment type, developers must actively configure the boundaries of compute consumption. This brings us to the next vital configuration parameter, the tokens per minute, or TPM, rate limit. To understand this parameter, we must first briefly review how generative AI models ingest data. A token is defined as the smallest unit of text or data that a generative AI model can process. Rather than reading whole words, models mathematically break input down into tokens, which can represent entire words, subwords, individual characters, or even punctuation marks, so they can understand and generate language efficiently. Because model inference requires immense GPU computational power, every single token processed carries a direct financial cost. Therefore, when you deploy a model in Foundry, you are strictly required to define a tokens per minute rate limit for that specific endpoint. This parameter is an absolute necessity for robust cost control and system stability. By explicitly capping the maximum number of tokens the model is legally allowed to process within a 60-second window, You proactively prevent runaway API usage caused by malicious actors, looping application errors, or unexpected spikes in legitimate user traffic. If a client application sends a volume of requests that exceeds this predefined TPM threshold, the Azure infrastructure will automatically intercept the requests and return an HTTP throttling error, intentionally blocking the transaction to protect the system. As an AI architect, your job is to configure this parameter high enough to support your application's expected peak user load, while keeping it low enough to prevent catastrophic budget overruns. The TPM rate limit is the ultimate financial and operational safety valve for your enterprise AI deployments. When interacting with the deployed endpoint, your client application code must be equipped to handle TPM enforcement. If your code submits a prompt that exceeds the rate limit, the API returns an HTTP 429 too many requests response. Developers must write asynchronous retry logic, commonly utilizing exponential backoff algorithms, to pause execution and smoothly resubmit the prompt once the minute resets. Observe the token evaluation workflow. Client app requests enter the system and undergo immediate token evaluation. If the request volume exceeds the strictly configured TPM limit, the system triggers an HTTP 429 throttling error. Now that we have configured the deployment type and established our precise tokens per minute rate limits, let us look behind the curtain to understand the infrastructure automation that occurs. When you finalize these parameters and deploy a model in Foundry, several critical architectural events occur simultaneously in the background. First, immense compute resources are automatically allocated. Foundry assigns the specialized hardware strictly needed to run the model. This includes provisioning CPUs, powerful GPUs, memory, advanced networking paths, and auto-scaling rules. Second, a secure API endpoint is immediately created. You are now able to securely invoke the model through the OpenAI Responses API, which is validated through strict management API checks. This endpoint becomes the permanent, unique HTTP address for your AI service. Third, your specific configuration, including the exact model version, foundational response style, and mandatory responsible AI safety settings, is permanently locked in for this deployment instance, guaranteeing that the model's behavior will not silently drift or change unexpectedly. Finally, robust monitoring and logging mechanisms become completely active. From the exact moment the deployment completes, the Azure infrastructure begins tracking all vital usage metrics, including raw performance, network latency, application errors, and real-time financial costs. This comprehensive telemetry is piped directly into monitoring dashboards, allowing operations teams to continuously evaluate the health of the AI system. Understanding this fully automated deployment lifecycle is crucial. It illustrates that configuring an AI model in Foundry is not merely about adjusting a few software settings. It is about dynamically orchestrating a massive, highly secure cloud infrastructure designed specifically to power your next-generation intelligent applications. To verify the success of the deployment lifecycle programmatically, infrastructure engineers often query the Azure Management REST APIs. By executing a securely authenticated GET request against the newly generated resource URI, developers can parse the return JSON payload to definitively confirm that the endpoint's provisioning state is succeeded and that all telemetry tracking is fully enabled. This diagram illustrates the fully automated sequence of events during a Foundry deployment. Once the model is successfully deployed and the foundational API endpoint is active, developers must configure the specific runtime parameters that influence the model's exact conversational behavior. These model arguments profoundly influence runtime performance, answer quality, and operational cost. The most efficient way to interact with a deployed model and discover these settings is to use the Model Playground in the Foundry portal. Within the Playground, you can easily configure critical parameters such as temperature and max output tokens. The temperature parameter is arguably the most important behavioral dial you possess. It mathematically controls the model's balance between creativity and determinism. If you configure a low temperature setting, the model becomes highly deterministic, consistently selecting the highest probability words. This is perfect for analytical tasks like writing Python code or extracting strict financial data. If you configure a high temperature setting, the model becomes significantly more creative and diverse in its vocabulary, which is ideal for marketing, copywriting, or brainstorming scenarios. The second critical configuration parameter is max output tokens. This argument explicitly caps the maximum length of the response generated by the model. This is not the same as the global TPM limit. This setting applies to individual inference requests. Setting a strict max output token limit directly affects token consumption and forcefully dictates throttling behavior per prompt. By actively experimenting with the temperature and token limits inside the Foundry Playground, engineers can rapidly validate their assumptions, compare different model families side by side, and capture the absolute perfect working settings before they ever write a single line of production application code. When writing client application code using the official Python SDK, these runtime parameters are passed directly within the API call payload. For instance, when invoking the completions.create method, developers must explicitly declare the temperature equals 0.7 and max underscore tokens equals 500 arguments. This dynamic payload allows the code to fine-tune the model's creative behavior strictly on a per-request basis. Here we visualize the runtime configuration flow. The user prompt hits the temperature configuration evaluation. A low temp routes to deterministic output, while a high temp routes to creative output. Beyond adjusting mathematical probabilities with temperature and token limits, developers must explicitly program the persona and constraints of the model. This is accomplished through the configuration of system instructions, commonly referred to as the system prompt. It is absolutely vital to understand the difference between a user prompt and a system prompt. The user prompt is simply the end-user request, question, or command passed from the client application. For example, a user typing, "Where should I travel for vacation?" into a chat window. Conversely, the system prompt is an overarching configuration parameter that firmly sets the behavior, role, tone, tools, and operational guardrails for the AI assistant. For example, you might configure the system instructions as, "You are a highly helpful, step-by-step mathematical tutor. You must always cite your sources. You must explicitly decline to provide medical advice." These instructions act as the model's absolute baseline reality. They govern how the model approaches the user's input, forcing it to maintain a specific corporate tone or strictly format its output as a structured JSON object. The system instructions are a foundational component of responsible AI, serving as the primary mechanism for preventing the model from discussing off-topic or restricted subjects. In advanced AI architectures, system instructions also explicitly define which external tools the model has permission to use, seamlessly linking the language model to external enterprise databases or APIs. When you configure your final application, these highly tuned system instructions are hard-coded directly into the application backend, ensuring that every single time a user interacts with the system, the model is perfectly constrained by your exact corporate requirements. In your codebase, configuring the system instructions requires structuring the messages array within your JSON payload. The very first object in this array must be explicitly assigned the role of system, containing your strict prompt string. This is immediately followed by objects assigned the role of user, guaranteeing the language model evaluates the overarching operational rules before it processes the specific user inquiry. This diagram clarifies the distinct inputs driving inference. As we conclude our intensive deep dive into AI model deployment options and configuration parameters, we must briefly look at how we integrate these finalized configurations into a real-world client application. A client application is a custom software program, such as a mobile app or a web portal, that actively sends formatted requests to the model endpoint and securely displays the generated response to the user. To successfully connect to the AI service, your application code uses the application programming interface, and you must explicitly configure your development environment variables. Your code requires 3 exact configuration parameters: the secure endpoint URI generated during deployment, the cryptographic API key to authenticate the HTTP request, and the specific model deployment name. The model deployment name is the exact custom string you provided to the model when you deployed it in Microsoft Foundry, which acts as the critical routing identifier. Furthermore, for ultimate enterprise security, your application code should absolutely never hard-code the API key in plain text. Instead, it should dynamically retrieve the credential from a highly secure storage solution like Azure Key Vault using a managed identity. By mastering deployment types, TPM limits, temperature controls, and rigorous system instructions, you guarantee your AI applications are robust, scalable, and secure. Thank you for joining this expert technical training session. We hope this deep dive has empowered you to architect phenomenal AI solutions. Please be sure to like this video, subscribe to our channel, and share this knowledge with your engineering teams. For those looking to rapidly accelerate their technical careers, visit quicktechie.com for our premium certification prep materials. At QuickTechie, we offer industry-leading Q&A banks, comprehensive ebooks, audiobooks, advanced training modules, and expert interview guides to help you achieve your ultimate goals. Build securely, configure intelligently, and we will see you in the next lesson. To execute this securely in Python, developers utilize the .env library to load the .env configuration file into memory. The osget-env function retrieves the highly sensitive Azure_OpenAI_endpoint and API_key variables safely at runtime. The script then passes these variables into the OpenAI client initializer, strictly preventing cryptographic secrets from ever being permanently pushed to a public GitHub repository.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by QuickTechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.